Okay, guys, so we're starting a new topic, sets. And I would imagine that some of you would have done sets before and would have a background knowledge of it. Let me see the hands of those who have done sets before and have some knowledge of what set is all about. All right, good. So it shouldn't be difficult then for you to give me a definition for sets.
Sir, set is a group of things together.
I'm going to ask you to repeat that. Lower your hand, Michelle.
Oh, sorry.
All right, so who was doing the defining now? Was that you?
Sir, me.
Yeah, go ahead.
Sir, I'm saying set is a group of things that are together.
Okay, group of things that are together. Any
Sir, such as elements and numbers and just a whole lot of things grouped together to make a set.
all right. Anybody else can give me their version of a definition?
Sir, I partly agree with her. I would say set is a group of things that but it has to be within concept. Like if you're gonna say the different type of trees in a set, it has to be about trees. If it's sons, then it's not really a set.
Okay. All right. Anybody else have any other idea apart from Ms. Clark and Ms. Shea? See the hands. Ms. Williams? Go ahead.
Sir, set is a collect usually of the same kind.
Okay, so all right, can you clarify that a little bit more when you say of the same kind, Ms. Williams? You can lower your hand though.
Sir, for example, you have a set of boxes or a set of coins or a set of balls. So they are exactly the same thing.
Okay. All right, so let me find out from anybody else. Ms. Clark, you had said something about set already, right?
Yes, sir.
Ms. Green, give me your idea of what a set is, please.
Containing more than one thing, sir,
Okay,
but they are the same.
okay. All right, Miss Amanda, can you give me an idea of what a set is? Not getting anything from Miss Amanda. Miss Cox?
Sir, it's a collection of things or items.
Okay. All right. So let me just comment on the definitions that you have been giving me. Your definition is a little too vague in terms of saying exactly what a set is. So first and foremost, we say that a set is a well-defined collection. When we say well-defined, it means that we can tell the members of a set based on how we define the set. So if we define a set, you shouldn't have any problem in identify what members or what elements belonging to the set based on how this set is defined, all right, or how it is described. All right, so we say then a set is a well-defined collection of objects or things. And the key word here is the well-defined. All right, so it means that you shouldn't have any confusion about what belongs to a set. So we can tell what belongs to a set without ambiguity. All right, so ambiguity here is just a big word for confusion. When something is ambiguous, it seems to have more than one meaning jumping out at you and you're not sure which of them is the correct one. All right. So without ambiguity mean that you wouldn't have any doubts as to what belongs to the set or what does not belong to the set. All right, so it's a well-defined collection. So for instance, if we talk about the set of things in a lady's handbag, then right away there should be some things that come to your mind that you would expect to find in a female handbag. Would you expect to find a gun in a female handbag?
Yes, sir.
Yes. Would all females walk around with a gun? All right, so it's not likely that you would have a gun in a setup as a part of a female handbag, but it's not impossible. All right, but suppose I say, would you find some hammer in a female handbag?
Sir, no, sir, but it is not impossible.
Right. So what we're saying then, you're not expected to find it in there. So we would say it doesn't belong to that set, right? So we can tell what belongs to the set from what doesn't belong to the set. Tell me some things that you are expected to find in a female handbag. Don't get too wild on it.
So lip gloss, a purse, money, and
all right, so those are some expected things. So you would have probably something to either do with a lip gloss or a purse, or what else you could consider as expected to be in a female handbag?
Sir, I will say pen.
What do you say, Mr. J?
Pen.
A pen. All right. So the point is, when you think of a set, immediately the members should jump out of you. You should know what belongs to the set. All right. All right. Now we have what we call set notation. Now the word notation here is just a fancy word for symbol. So it's a big word that we use when we're talking about symbol. So instead of saying set notation, we could actually say set symbols. So notation is a big word for symbol. Now, we are going to be looking at some symbols that we'll be using in this topic, because these symbols, you're going to see them quite often. And so it makes sense for us to be familiar with them before we start learning, before we start using them. And so we will try to find the meaning of these symbols, because in math, every symbol has a meaning, and the meaning, they are very specific. So you have to be careful not to loosely just look at a symbol and think the meaning of it is a loose thing. So we're starting off with the curly brackets, and the curly brackets simply mean the set of. And so when you see these brackets, the meaning of it should come to your mind. So you read it in accordance to what the meaning is. So this means the set of. So if you're looking at a mathematical statement with the brackets, you have to read it, the set of. And this second one now, where you have this, what you call this now, the brackets here with A inside, and you have the common letter N outside. So the N outside means the number of elements, and the A inside tell you the set. So the N means the number of elements of the set. Inside here now we have A, so that would be of the set A. All right, so this symbol means the number of elements of the set. A. So please pay attention to the meaning, students. Here now we have another symbol, has the curly brackets. So anybody remember what the curly brackets mean? I mean, it goes without saying. It is right there on the screen. So the curly brackets, they refer to it as the braces sometimes, mean the set off. So here now in this symbol here, you have the curly bracket. So you have to read it, the set off. And then now, so the curly bracket means the set off. And then now we read from left to right. So the set of elements X. Now, these two dots referred to as the colon means such that. So the set of elements X, the colon means such that. Is everybody clear on the meaning there? Let me see your hand if you understand how to read this. All right, so everybody is good. No question. All right. Miss Green? Who is breaking up
I was
there?
asking you to just go over one more time, sir.
Okay, for the third one.
Sir?
Yes, I'm
Yes.
hearing.
Yes,
So
sir, for that one.
we are saying that once you see the brackets, the braces, you always start off reading the setup. So here we have the braces. So we have to start off by saying the setup because we have the braces, right? So we say the setup, and then now inside the braces, we start read the set of elements X. So this part now would identify what element we are referring to. So the set of elements X, and then the colon now, which is the two dots, means such that, right? So the set of elements X such that, and then now sometimes you would have some statement that comes after this, right? But this is the general notation. When you're going to describe a set, you will probably start it off in this way. And there are many different ways that we can describe a set. All right, so moving on. Is that clear enough for you, Ms. Green?
Yes, sir.
All right. Here now we have this kind of looking like an E, but it's really not an E. But it means is an element of. So this symbol means is an element of or is a member of. So you can read it either ways. You can read it as is an element of, or you can read it is a member of, whichever way. Sometimes when you get a little bit more familiar with it, you may read it even in a more simplified way. But for now, just bear in mind, it means is an element of or is a member of. Is that clear? Everybody clear on that second symbol there? I mean that fourth symbol. All right, moving on. So clearly now, whenever we have a stroke drawn through a symbol in a diagonal sense, the stroke here means not. So this mean is an element of, and then you put a stroke through it, it now becomes not. So it is not an element of. So this stroke would negate it, meaning it turns it into a not statement. All right, moving along. Now, so you can say is not an element of, or you could say not a member of. Now, this fancy curly E looking symbol, or you may have this fancy curly U, means the universal set. So that's what these symbols refer to, the universal set. Now, these symbols are a little bit from the earlier times, or should I say it's a little bit more on the older version of symbols that are used to represent the universal set. Now, in recent times, you will just see a simple U. That means universal set. So in the older versions of symbols, they would have this curly looking thing when they're referring to the universal set. Now, it is more simple. It's just a simple U, which means the universal set. All right, moving along. So here we have now, this means the empty or null set. Now this symbol is actually, it's actually a Greek symbol. This diagram is not a good representative of it. It is a Greek symbol that usually looks like this. All right, that's how it usually looks. And the symbol is a letter from the Greek alphabet. And in the Greek alphabet, it is called phi, right? You know about pi already. This one is called phi. Now, it is always used in sets to mean the empty set or the null set. So what that is telling you, that tells you that you have a set with no members. So it is empty. Now, this symbol looking like a U means union. And this one that looks like an N means intersection. This one look like a sideways N is a subset of. This one with a dash, the complement of set A. Now, if you notice how we spell this complement, it is not spelled with an I, it's spelled with an E. So when it is spelled with an E, what does this complement mean? Can anybody tell me what this complement means?
Sir, empty? No, sir, no, mistake.
The one that's...
Sorry, yes, sir. Can I try?
Go ahead, Miss Cox.
Sir, it can basically found in all sets.
All right, it still does not tell me exactly what this word means though. So I want you to tell me what the word itself, what the literal meaning of the word. From a dictionary point of view, a definition for the word. When it's spelled with an I, what does it mean when it's spelled with an I?
Sir, when you're giving a compliment to someone.
Right, that's when it is spelled with the I. But when it's spelled with an E, what is it saying now? Anybody? Miss Green, help us out now. Miss Cavero, you want to add something?
I don't know the literal meaning of the word, but I know in sets complement mean basically everything that is not in that set.
Okay. All right. So what is not in the set? All right. So in the context of a universal set, it usually denotes what is outside a set, but what is outside the set, but what is also inside the universal set. But if you understand what the word actually means, then it will be easier for you to understand the concept and how it is used when we are working with sets. Mr. Shamar, any idea what the word means?
Complement, sir.
Yeah.
I'm not sure. But maybe. So I'm tempted to go Google this one, but all right, I'll just be honest. I don't know.
All right, Miss Williams, I saw you put up your hand. What is the word? What it means?
Sir, it means to improve or enhance something.
Okay. All right. I probably can't see how that might fit in in that, but not completely what I'm expecting. Miss Waysome, you want to add something?
Sir, to contribute extra as to improve quality.
All right, to contribute extra. All right, so in mathematics, it really means to complete. Right? It means to complete. So when we talk about complementary angles, we're talking about angles that add together to complete a 90-degree angle. So if you have two acute angles and you add them, you get 90 degrees. But these two angles, we say that they are complementing each other, meaning that both of them together complete. Now in sets, generally we have a set A and we have a complement of a set A. So if A is a set denoted by a circle and whatever is in the circle would be the set A, then anything outside the circle would be the set A complement. But what that really means in the context of a universal set, the set outside A is also a set. Because if you consider that you have the shaded region, it is really a space where other elements can be. So anything outside A together with whatever is inside A will complete the universal set. So that's why they complement each other. When you add A plus A prime or A dash or A complement, you will get all the elements in the universal set. Is that clear, guys? Everybody understanding what I'm saying? Let me see the hands.
Yeah.
Right, so in the context of set, a complement or a complement of a set would be the set that together with a set with its complement will complete the universal set. All right, moving along. So we can, oftentimes this is called complement of set A. Sometimes we say A complement, or sometimes we say A prime. Whichever of these terms we use, it means the same thing. Complement of set A complement, A prime, same thing. Here now, we would have met Z before when we were looking at the number system. And Z would represent, Z is a symbol for the set of all integers, right? Now we know that integers are what kind of numbers? Ms. Shea, you want to say something?
Sir, integers are positive or negative numbers.
Yes, so they're positive and negative numbers. Now, if we want to make a distinction with whether or not we're working with positive or negative numbers in terms of the Z, you may sometimes have a plus sign put here. When you see a plus sign there, it means that they are referring to all the positive integers. And if they put a negative sign there, then of course that would mean you're dealing with all the negative integers. All right. So based on what sign is here, if you don't see any sign, that means you're dealing with all integers. Is that clear, guys?
Yes, sir.
All right, good. So here now we have a Z with a plus, set of all positive integers. Now Q always is used to represent rational. So that's a symbol that we use in maths to represent rational. And it is generally is a capital Q. And sometimes it is written in the Old English style. So you may have something looking like this. And that's how they usually represent rational numbers with that Old English Q. All right. All right. Here now. So those would have been all the symbols that you should be familiar with. And so you're going to be seeing all of these symbols as we move along through this topic. All right, so it is good to know them. All right, so moving along now. We say that some sets have special names. And you see, it goes back to what we say, that a set is a well-defined collection. So if it is well-defined, we are able to classify them with names, right? Now, a pack of cards. Now, we know when we talk about a pack of cards, we are expecting certain members of that pack, all right? We can say a fleet of ships. We can say a pride of lion. So all of those are sets with special names. I mean, we could come up with some others. Any other example you could come up with?
A school of fish.
A school of fish. Right, so those are set with special names. All right, moving along. Definition: the things belonging to a set are known as members or elements of a set. And so we would say the elements of a set may be specified in two ways. All right, now specify mean that we can specify the set by listing the elements. And in maths, when we say list the elements in a set, you have to use certain symbols in listing. You have to use the curly brackets when you're listing the set. Because remember, the curly brackets mean what? What the curly bracket means again? Anybody? What
The set up.
The set up. So in listing a set, you always have to have the curly brackets to denote that it is a set. So the set of, and then you list the members within the set. So here we would list 2, 4, 6, 8, 10. Now clearly, we see that these members may have certain characteristics to them, and you could probably further describe what this set is. What would you call this set if you were describing it?
Even numbers, sir.
All right, so would it be correct though to just generally say even numbers?
Set up even
Sir, you
numbers.
can say a set of even numbers.
Not just a set of
Less than 10.
right, so you have to specify. Specify mean you have to tell where it starts from and where it ends. So the set of even numbers from 2 to 10, or the set of even numbers between 1 and 11. So that's how we specify it, you know, because we can't just say even numbers, because even number encapsulate more than just these few even numbers. You follow what I'm saying? Because this set does not consist of all even number. Does it consist of all even numbers? Guys? Miss Cox, does this set consist of all even numbers?
No, sir.
No. So we can't just loosely say the set of even number. We have to really specify what even numbers we are referring to. The ones from 2 to 10. All right. Any question, guys? All right, so we can specify 2 ways by listing the elements. So here we can list some letters of the alphabet. What do we call these letters of the alphabet though?
Vowels.
Vowels. All right, so here we actually are listing the members. So the next description now, the next we have specifies by description. So now we, in describing, we say what they are. So here we would have the same curly bracket, the set of, and we say what the numbers are. The set of even numbers between 1 and 11. Or we could say the set of even numbers from 2 to 10. Now, the other set would be the vowels, the set of vowels in the alphabet. Notice that I always start off the set of, because we have to read the curly brackets when we're looking at it. So the set of vowels in the alphabet. All right, so we have seen 2 ways of specifying set, one by listing, the other by describing in terms of word. Now there's a third way that we describe sets, and this is now called description by set builders notation. Now set builders notation is a description where we use symbols to describe what the set is. So here we have a symbol now. Remember that symbol that we were describing when we were going through the list? Who can read who can read this description here? Can somebody try reading it for me? Miss Cox, you don't want to try.